students, and here I am going to discuss the problem from NCERT book exercise 6.2 question number 10. Here I am going to explain for you. Okay, and this is another interesting question based on the concept of the basic proportionality theorem and converse basic proportionality theorem. Okay, in this question it is given that the ABCD is a quadrilateral and the diagonals, okay, of the quadrilateral ABCD intersect each other at the point O, and AO by BO is equal to CO by DO, so that ABCD is a trapezium. So students, it is given that it is a quadrilateral, we have to prove it is a trapezium, so we have to do the diagram according to given part, according to axing part. What is question is axing, always you know, okay, and what is question is axing, we have to the diagram accordingly. Here it is a ABCD is a quadrilateral and to prove it is a trapezium, so our diagram should be in such a manner that it should look like a trapezium. Okay, okay, and you see now here you see ABCD is a quadrilateral and the diagram looks like a trapezium because you have to prove it. That's why the diagram should be accordingly. And ABCD is a, but ABCD is a quadrilateral. ABCD is a quadrilateral given. ABCD is a quadrilateral, not trapezium. We have to prove it. ABCD is a quadrilateral, not trapezium. Is a quadrilateral. Understand? And another thing you see, the diagonal AC and BD intersect at the point O. Intersect at the point O. Okay, and diagonal AC and BD diagonal intersect at the point O. At the point O. This is another given. Okay, and again given that AO upon BO is equal to CU upon DO. Okay, that it is also another fact given that AO upon CO is equal to BO upon BO. AO upon BO is equal to CU upon DO given. Okay, understand? So this much given, and you have to prove that ABCD is a trapezium. It means we have to prove that one pair of opposite side AB must be parallel to CD. Then it can be a trapezium. Okay. Now for construction, one more construction we have to do, because we have to prove it according to the basic proportionality theorem and converse basic proportionality theorem. That's why you have to draw a line through the point O. Draw a line to the point O, a line, okay, and MN is drawn through the point O in such a manner that MN parallel to AB. Is it clear? Now the line MN is drawn through the point O such that AB parallel to MN, AB parallel to MN, AB parallel to MN. Okay, this is the construction for the given question. Now let us prove it. Okay, understand? Is it clear? Okay, okay. Let's see. This is the given, and this is the what to prove, and you have to prove it is a trapezium, and also the construction you already know. What should be the construction? Let's see how to prove this one. Let's see how to prove. Okay, students. Now let us see. Now see in the triangle ABD. In the triangle ABD. In the triangle ABD. What are you finding? MO parallel to AB. Why? Because as per the construction MN parallel to AB, it has been constructed. So since MN parallel to AB, MO parallel to AB, because MO is the part of MN. Since MN parallel to AB, so MO also parallel to AB. So you can use the basic proportionality theorem. Yes or no? So what you use? AM upon DM is equal to AO upon CO. by BPT. Okay, by basic proportionality theorem. Understand? Is it clear? AOY? Yes or no? Yes or no? Again you see in the triangle. Yes. In the triangle ABD, I think you see AM upon DM is equal to no BO is equal to DO. There is a mistake. Sorry, extremely sorry for that. Because you see DAV. Look at here. Look at the diagram I am doing. Here DAB is a triangle. In this triangle, what? MO parallel to what? AB. So AM upon DM is equal to BO upon DO. Okay. BO upon DO. This is one of the mistaken. Okay. Is it clear? Okay, because OM parallel to AB. OM parallel to AB. So AM by DM is equal to BO by DO. This is one of the mistaken and it is correct. You understand or not? Okay. Is it clear? Similarly, you see in the triangle, another triangle ABC. In the triangle ABC, look at in the triangle CAB triangle. In triangle CAB, look at here. The triangle CAB. In the triangle CAB, can you say ON parallel to AB? Yes or no? OM parallel to AB. So, can you say AO upon CO is equal to BN upon CN? Yes, okay. Similarly, in the triangle CAB, look at here. AO upon CO is equal to BN upon CN. BN upon CN. Same concept of the BPT, basic proportionality theorem. Understand? Since ON parallel to AB, so OA upon OC is equal to BN upon CN. Right? Understand? Okay. Again given that, what is given you see? AO upon BO is equal to CO upon DO. Yes or no? Okay. So that implies AO upon CO will transpose CO. Okay, will be transferred to the left hand side. So numerator will be denominator. BO goes right side. It will be BO upon DO. Can you write or not? Can I write or not? Yes. Okay. Understand? So now let's see. Okay. Now see AO upon CO is equal to BO upon DO. And again AO upon CO is equal to what? You see now again AO upon CO is equal to BN by CN. BN upon CN. And AO upon CO is equal to BO upon DO. Okay. Look at it once again. AO by CO is equal to BA upon DO. And BO by DO is equal to how much? A upon AM upon DN from the equation 1. Yes or no? Yes or no? You can write AM upon DM. Clear? AM upon DM. Right? Okay? Understand? Okay. Here you see. Look at here. From this you see, closely you observe here. You see now AM upon DM. AM upon DM is equal to AO upon CO. AO upon CO. You can get another point also from this, from the previous statement. You can write AM upon DM is equal to AO upon CO. Right? Now you see the triangle ACD, OM parallel. Now look at here. In the triangle ACD, what are you observing? You see AM upon DM is equal to AO upon CO. It means according to converse basic proportionality theorem. According to converse basic proportionality theorem. Can you prove? Can you prove OM parallel to CD? Can you prove? Yes or no? Yes, can you prove? Okay, let's see. Now see, look at here. Look at here. In triangle ACD. Look at the triangle ACD. In triangle ACD, AM upon DM is equal to AO upon CO. AO upon CO. Okay, from the equation 3. From the equation 3. From the equation 3. Okay. So since, okay, look at here. Look at here. Look at here. This is A, this is B, and this is C, and this is what? M, this is O. And you see AM upon DN is equal to AO upon CO. So this is in accordance with the converse basic proportional theorem. We can write MO parallel to CD by converse BPT. By converse BPT. By converse BPT. Okay, and since MO parallel to CO, CD, and MA means what? If MO parallel to MO means what? MN or not? Because MO is a part of MN. So since MO parallel to CD, so it is clear that MN also parallel to CD. That implies MN parallel to CD. Understand? MN parallel to CD. Yes or no? Yes. And again it is given that since MN parallel to CD, then after that what? AM upon DM. Okay. Again you see MN is parallel to AB. MN parallel to AB since construction as per the construction. Since construction already we have done. Okay. So since MN parallel to CD and MN parallel to AB, so hence AB parallel to CD. Since AB parallel to CD, so one pair of opposite sides are parallel. So hence AB parallel to CD. So we can say this is the sufficient condition that if one pair of opposite side of a quadrilateral is parallel, then ABCD is a what? Trapezium. ABCD is a trapezium. Okay, and this is how you can use the concept of the basic proportional theorem and converse basic proportional theorem to prove the geometrical statement. A quadrilateral can be trapezium under certain condition. Okay, using the concept of BPT and converse BPT, and this is another example of converse BPT basic proportional theorem and converse basic proportional theorem. So, and you can study there are many geometrical statements. Okay, and they are vital. Okay, and they are the statement which can be proved using the very important concept of the basic proportional theorem and converse BPT theorem. Okay, understand? So this you learned. You will learn something else about it. Okay, how can you use the concept of the theorem of BPT and converse BPT in proving the geometrical statement. Okay, thank you. I hope you will practice it. Okay, see you. I hope. Thank you for your interest. Okay, next. Thank you.